and we'll go ahead and get the PowerPoint presentation pulled up. Okay. All right, so Tony, we're going to kind of let you be the scribe again, in that we're going to make sure that the PowerPoint's looking good and all that kind of stuff. If you do that for me, please, like we normally do.
Will do, Joe. You're in. You're not in. Yeah, there you go. All right, looks good.
Everything look good?
Yeah.
Yes, sir.
All right, well, fellas, again, today we're going to be doing HMH7 heat pump overview. And this is a really neat product. It actually modulates from 35 to 100% capacity. And as you take a look at those two pictures, you'll notice there's actually two platforms. The one on the left is a 4 or 5 ton unit. That's the 2 fan model. And then there's going to be a single fan model. It'll be the 2 and 3 ton. And these come in whole tonnages, 2, 3, 4, and 5 ton. And as Tony mentioned, they are not a mini split. They look like a mini split. They share some similar technology, but you're going to treat them just like a regular plain Jane heat pump. In other words, you're going to wire it up like a heat pump, use a conventional heat pump thermostat, and you're going to use a normal expansion valve, just a standard heat pump coil and expansion valve on the indoor product. And just, again, install it, keep it clean, keep it dry like you would any other refrigeration circuit, and you'll be ready to rock and roll. So one thing we would ask everyone to please remember, the unit service fittings are 5/16. And in order to adapt that down to your 1/4-inch service hose, you're going to need an adapter. And these are very, very common. You'll see these. Most guys have them on their trucks already. But they're a 5/16 female down to a 1/4-inch flare adapter, so you could get your service hoses on there. So we get quite a few questions, fellas, on, hey, what's my outdoor coil temperature and indoor coil temperatures, minimums and maximums. So this little chart right here, this is in our install information. You're going to notice that, even in the cooling mode of operation, 35 degrees is minimum cooling. And in the heating mode of operation, -5. So I know down there in Florida, you guys will never see those temperatures more than likely, but it's nice to know that there are some min-max numbers. And on the high side, or on the the maximum numbers, 122 degree outdoor cool temperature, which is pretty high, and 75 degrees for heating. So it's a very, very broad range, of application. In addition, Tony can send you some expanded ratings. He's got a real nice little chart that he can share with you at some time, where there are some expanded ratings all the way from 60 down to about 0 degrees, if you have that need. Today, guys, we're going to start out with the AE air handler. Now, the AE air handler is just our standard ECM motor air handler. And when I say standard ECM, there's 2 types of ECM motors, or high efficiency motors. One is a standard ECM motor that's going to just have speed taps on it, just like a regular motor, 1, 2, 3, 4, 5. The variable speed ECM type of motor will have a control board where you're going to be able to make airflow adjustments with some jumpers on the board. So that's the main difference between them. Is the standard ECM type of motor product is going to have the capability of just doing jumpers. And you're just going to, just a regular speed tap. And then on the variable speed, you'll have some jumpers that you'll make on a control board. We're going to go over the low voltage wiring with this AE air handler with a simplified block wiring diagram. Now, please remember the AE air handler has no terminals, but it's equipped with pigtail connections. Now, we're going to be showing kind of a block on there, but just remember it's a pigtail connection. But in the PowerPoint, it's easier to show just like a block or a terminal than it is to like draw a wire, that type of thing. So we're just going to show that, but just remember it is pigtail connections. In addition, we're going to talk about using the accessory single pole double throw relay kit in the indoor unit and how it's going to be used for airflow reduction. Now, we're going to recommend utilizing that HMH7 K001 kit for convenience and supplied parts. It should be noted the 002 kit may also be used. However, one of the relays, the RV relay, will not be needed for this particular application. So please remember this little install kit is going to be needed for to hook the thing up, a single pole double throw relay. However, the burning question often comes, hey, what if I don't have that kit? Can I provide my own field wiring and my own bi-flow filter dryer and just a little peanut relay, a little single pole double throw peanut relay? And the answer is, of course you can. However, we do recommend the kit for convenience and the supplied parts and the harnessing it's already made up in that kit. In addition, a heat pump thermostat, the BO selection will have to be used for the reversing valve operation. Now, all of our other Champion products, we energize the O terminal for cooling mode of operation. On this product, we're going to energize the B terminal for heating mode. It's just exactly opposite. Now, it's not bad, it's just different. So please keep in mind that your thermostat, your heat pump thermostat, has to have that BO selection so you can energize reversing valve in the heating mode of operation with this product. Any questions or comments so far?
No, I think we're good.
Well, fantastic. All right. Well, so let's go ahead and start out with just a simplified block wiring diagram. Fellas, like I said, on this particular product, we're going to be taking that B terminal outside from the thermostat. Now, this is just going to be a conventional heat pump thermostat. Nothing fancy. It is not communicating. Make a little note of that. This is not a communicating system. However, from the intelligence on the control board outside, it's going to modulate between 35 and 100% capacity. So that's pretty cool. So that B terminal goes straight outside for reversing valve operation in the heating mode. If you have a two-stage heat strip inside this air handler, W2 will be our second stage auxiliary heat on that heat strip. W1 will be our first stage auxiliary heat on the heat strip. And we're going to carry that wire all the way outside as well, because during defrost, we want to bring on a stage of heat strip when the unit goes into defrost. That way we don't freeze the homeowner out. Because remember, guys, when anytime a heat pump goes into defrost, it's actually going into the cooling mode of operation to defrost that outdoor coil. So we want to bring some heat strip on during defrost so we don't freeze Ethel out when she goes to defrost on her heat pump. Y terminal goes outside. That's going to be your compressor call. Now, I want you to notice something on the HMH7 right now. You only need, to get all this function outside, you only need a single Y wire going outside. You don't have like a Y1, Y2, Y3, Y5, or whatever outside. It's just a single Y terminal outside for compressor call. And then the outdoor unit, by looking at a bunch of sensors, it has an outdoor air sensor, a liquid line sensor, a suction line sensor, a discharge line sensor, and so on. So by looking at different temperatures and sensors, it makes intelligent decisions on what point of modulation it needs to be at. So this outdoor unit is going to modulate 35 to 100% capacity with just a single simple Y signal outside. It should be noted also on the ECM motor, sometimes you're going to find them equipped with a yellow wire on that ECM motor. Go ahead and take that yellow wire off the ECM motor, because what we're going to do with our HMH7AK001 install kit, the relay kit, you'll have some wires that you're going to make back on that ECM motor from the relay itself. So if it does have, now this is very typical, if it's equipped, take that yellow wire off from the factory during install. B terminal is your 24-volt common. That's going to go from the thermostat to the indoor unit to the outdoor unit. You would expect that. And typically that's going to be a blue wire, but use whatever wire you want as long as you keep track of that common terminal. The R terminal's 24-volt hot. It's going to go from the thermostat to the indoor unit. Now, guys, this is really important. You do not, let me say it one more time, you do not take an R terminal outside. The outdoor unit does not require 24-volt R terminal outside, which is kind of different too, but it's kind of cool in a way as well. You don't have to take that outside. And G is going to be your fan call. And we're going to recommend that you're going to go ahead and put that G on the lowest speed tap on the ECM motor. Because remember, if the homeowner wants to go to the thermostat sub-base assembly and just run fan only and just turn the fan on, how fast does it run on just circulation? Well, typically that's going to be the lowest speed tap is what's recommended. Okay, let's talk about wiring that relay up. So one side of the relay coil itself, it's a 24-volt coil on the relay, single pole, double throw switching contacts, 24-volt coil. So one side of that coil is going to go up to S1. Now S1 will generate a 24-volt output on S1 when it wants airflow reduction. So one side of that relay is going to go, the relay coil is going to go to S1. The other side of the relay coil itself is going to go to common. So there you see that when we energize S1, it's going to switch that relay. Common terminal for the switching contacts, the common terminal for the switching contacts is going to go up and grab that yellow wire. So anytime we have a compressor call, we're going to energize the common terminal of the switching contacts. On the ECM motor, we're going to go ahead and select a high speed tap, like speed tap number 5, and we're going to tie that up onto W1 so that anytime we have an auxiliary heat call from the thermostat or whenever we go into defrost, we're going to call for that high speed tap on the ECM motor. Normally closed, the normally closed contact on the relay. Now remember guys, with the relay just sitting there de-energized, the coil's not energized, the normally closed contacts, we're going to select 100% cooling airflow. So fellas, you're going to have to, measure your airflow, and you're going to select an airflow setting on that motor with the normally closed contact to give you 100% cooling airflow. Now, please make a note of this, or please remember this. We always want you to set your airflow up at 400 CFM per ton. So if I've got a 2-ton unit setting outside, 100% cooling airflow is going to be 800 CFM. If I've got a 3-ton unit setting outside, it'll be 1200 CFM and so on. So this is your 100% cooling airflow call on the normally closed contact. Then on the normally open contact, of the relay, we're going to go over and we're going to select a speed tap that's going to give us about 60% airflow. Now, if you get in a situation where your airflow is anywhere between about 60 and 65%, that's plenty close for field work. I had a contractor the other day say, Joel, the closest I could get to 60% was actually about 58% or 57%. Is that okay? And the answer is, of course it is. And so we don't want too much airflow on this. We don't want like 80% airflow, because then you're going to have humidity issues because you haven't slowed that fan down enough as that outdoor unit starts going into lower points of modulation. So please remember, guys, this relay, the only reason that relay's there is to give us airflow reduction. When the outdoor unit starts screwing down to about 70% capacity, something like that, it's going to reduce the airflow inside by switching that relay. And we're going to show you that in just a second with an animation. But is there any questions or comments on this block wiring diagram and how we're going to wire this thing up on the AE air handler? Any questions or comments so far?
Yeah. So basically, that's going to give the air handler the ability to run at either 100% or 60%, and then the condenser will modulate anywhere from 30 to 100.
Yeah, 35 to 100%. That's a great question. So basically, once that outdoor unit starts screwing down to about 60 to 70% capacity, something like that, it's going to generate an S1 signal, and we'll show you that animation here in just a second. It's going to generate an S1 signal, 24-volt signal on S1 output from the outdoor unit. It's going to switch that relay and then switch the airflow inside to more closely match that capacity. So now the burning question is, well, Joel, if I'm at 35% or 40% capacity, am I still going to have 60% airflow? And the answer is yes, you will. So we're kind of compromising a little bit with just 2 airflow taps, but 60% and 100%, that's going to give you, very, very close to your capacity at any given point. Good question. Any other good questions or comments?
Nope, think we're good.
Okay. All right, well, fellas, I'm going to just please watch the animation. So let's say the outdoor unit starts screwing down to about 60%, 65% air or capacity. Bang, what it's going to do is going to energize that S1 terminal. Let me back up and show that animation again. So what it's going to do, if you have an S1 output, bang, it's going to switch that relay. And you're going to notice that output from the outdoor unit, that S1 output from the outdoor unit switches that relay, and it's going to command reduced airflow on the indoor unit by way of that relay. So that's all it does. That's all that relay does in this application here, is it just switches the airflow to a lower airflow setting and based on the outdoor unit's point of modulation. Good. Any questions on that?
Don't think so.
Okay, yeah, pretty straightforward. Please note that if you get a W1 call at any time, during the heating mode of operation, even if you're in reduced airflow, what's going to happen with any ECM motor, if you have more than one speed command going to that motor, it's going to always take the highest of the speed commands that it's receiving. So let's say, for instance, you go into a defrost mode of operation. You go into defrost, what it's going to do is going to drive that fan to high speed. Even though it might be on a lower speed, it's going to drive it to high speed because you're going to have a higher speed command with that defrost call or that auxiliary heat call. And as a quick reminder, again, you're going to have a W1. It'll be present with a auxiliary heat call or during a defrost call. Well, at this time, we're going to go ahead and cover, I know you guys probably don't sell a lot of furnaces down there, but we were asked to do the entire program for you today. So we're going to go ahead and just review real quick with a TME and a TMY standard ECM motor furnace. It's going to be the same type of wiring scheme, and we're going to use the same type of single pole double throw relay with it as far as the 001 kit. However, you want to make sure that on any kind of furnace product, if you guys should happen to ever put a furnace in, that the heat pump thermostat's going to have the BO selection just like we had before. In addition, you're going to have to select the heat pump thermostat with dual fuel function if you happen to match it up with a furnace product. Okay, so you're going to notice this looks pretty much the same as the last one because it is. This TME single stage furnace is going to wire up exactly like the air handler. The only difference is you're going to notice that the terminal designations are a little bit different. We have a Y1 and a Y2 terminal designation that just looks a little bit different. Plus, you have to have a dual fuel thermostat with a furnace. But other than that, the TME is a single stage furnace, so you wouldn't even use the W2 anywhere. But W1 would go all the way through from the thermostat to W on the furnace to W outside. Y is going to do the same thing. It's going to go from the thermostat to the outdoor unit. Common's going to stay the same all the way through. You'd expect that. R goes from the thermostat to the indoor unit. And then G goes from the thermostat to the indoor unit. Now, where it's going to be, like I said, a little bit different, we do have some terminals that are given a little different designation, Y/Y2 and so on. But as far as the relay is concerned, fellas, it's going to wire the same. You're going to have one side of the relay coil going to S1. The other side of the relay coil is going to go to common, just like before. And the common terminal of the switching contacts will go to Y, just like before. Now watch this, your normally closed contact will go to Y/Y2. You actually have a terminal on a furnace, a terminal on the furnace board that's called Y/Y2. You'll take your normally closed contact to that, and then the normally open contact to go up and hit Y1. So it's essentially the exact same thing we did on the AE air handler. It's just that we have a little different terminal configuration on a furnace, and remember, they're hard screw terminals. Now, fellas, watch this, a two-stage furnace, a two-stage heat and two-stage cool furnace, it wires exactly like the one we just talked about. Everything stays the same. The only difference is you're going to have a Y2 and a Y and a W/W1, a W2 and a W/W1 for the heating terminals. And at that point, your thermostat will have to be a two-stage heat, two-stage cool capable, a two-stage heat, one-stage cool capable thermostat. W2 will go to W2. W1 will go to W1 or W/W1 and then outside. So very, very simple. Even if you should happen onto a furnace product, you probably wouldn't see too many down there, but if you did, you would be able to wire it just like this. And then if you go in and look at the animation, it's the same thing. We're just switching that relay to give you low airflow or reduced airflow anytime you have a point of modulation of about 60% outside. It's going to switch that relay and give you lower airflow. Any questions or comments on the ECM motor products before we jump into some variable speed motor products as we start looking at how we'd utilize a different relay kit? Any questions or comments on these ECM motor products?
No, sir.
Everybody good? Okay. So anytime we have a variable speed anything, whether it's a variable speed air handler or a variable speed furnace, we're going to have a little different relay arrangement. As a matter of fact, on the variable speed air handler or variable speed furnace, you're going to have to use the HMH7 kit, the HMH7 kit. Now, this kit comes with 2 relays, fellas. It comes with 2 relays mounted on the board, and they're designated RV and S1. Now, another thing about the variable speed air handler and furnace, we're going to still look at a simplified block wiring diagram like before. However, the terminals that we're going to be talking about on this are not going to include like your HUME and your DHUME and your EAC terminals, because they have nothing to do with the function outside. So just remember, if you've got a variable speed air handler or a variable speed furnace, you're going to have some different options on airflow. You're going to have a dehumidification capability. You're going to have a humidifier and all that stuff. But again, those are kind of internal things that you would use internally. It has nothing to do with the function outside. So we're not going to talk about those, but just remember, you do have some advanced features on a variable speed product. In addition, if you do happen to have a heat pump on a furnace, a variable speed furnace, please remember you're going to have a dual fuel function with that thermostat. So this time we're going to go ahead and take a look at a simplified block wiring diagram. You're going to notice there's going to be two relays. They're going to be designated RV and S1. And so let's take a look at that right now. So here we have a variable speed air handler. And by the way, the variable speed air handler works really, really well with this outdoor unit. It's a real good matchup as far as capability, because you can actually set up on your control board on a variable speed air handler or a variable speed furnace. You can actually set up on that control board some advanced cooling on delay functions if you have a humid environment, which you guys would have down there in Florida. And so there's just a lot of neat things you can do with the variable speed air handler that you can't do with an AE air handler, but it's just something to think, certainly think about as an upsell opportunity, because the variable speed air handler does give you more humidity control and better airflow control, basically, on those humid days. So anyway, with all that said, let's take a look at how to hook up a variable speed air handler with our HMH7 heat pump outside. So just like before, we're going to take that B terminal outside. That's going to be for reversing valve operation, just like we had before. If you have a 2-stage heat strip inside, W2 from the thermostat will go to W2 on the air handler. That's going to be your 2nd stage auxiliary heat, if it's so equipped. W1 will be your 1st stage auxiliary heat. That'll go from W1 on the thermostat to the air handler and then to the outdoor unit. Looks very, very similar to what we just had on the AE air handler, because it is. It's just that we've got variable speed product now. Y terminal goes outside just like we had before. That's your compressor call. C terminal goes all the way through. R goes from the thermostat to the indoor unit, does not go outside. And G is your fan call. Now again, where the variable speed product is a little bit different, it has 2 relays. It has an RV relay and an S1 relay. Let's go ahead and wire up that S1 relay like we did before. We'll do that one first. So you'll notice that the common, both sides of the relay coils are going to go to common. Both sides of the relay coils are going to go to common. The other side of the relay of S1 relay, so the relay coil on S1 relay is going to go up to S1. And so basically your S1 relay is going to be your airflow reduction relay. That's the one that you're looking at right now. The S1 relay will be your airflow reduction relay. We're going to grab 24-volt common on the Y signal and go down to the common terminal of the switching contacts on the S1 relay. Normally closed contact on the S1 relay will go to Y/Y2. That's your high-speed airflow. And on your normally open contact of your S1 relay, that's going to go up to Y1. Now, please remember, on a variable speed air handler, you guys don't have to select a speed tap like you did on an AE air handler. You're just going to go to the control board, and whatever you set up on the control board for your full airflow list. So let's say you got a 3-ton unit, and you set your jumpers up for 1200 CFM on your cool and adjust jumper. Once you do that, if this board sees a Y1 call for airflow reduction, the board itself will automatically go to 65% airflow. So you don't have to try to select a speed tap. The board itself, once you set your cooling airflow up between cool and adjust jumper, as soon as that board sees a Y1 call, but it doesn't see a Y2 call, what it will do, it'll reduce that airflow back to 65% just from the board itself. So the board knows to do that. It's programmed to do that. Any questions or comments so far on that?
The ABC, it has the board that's attached to the blower.
One more time, what was the question?
The ABC has the board attached to the blower, correct?
That is correct. Good question. So if you take a look at the blower compartment on the ABC air handler, there's going to be like a little sealed box. You just pop the cover off that sealed box, and then you'll see the connections inside that sealed box. That is correct.
And the relay kit goes inside that box, or are we mounting the relays up like in the heater compartment and wiring it down?
Wherever it's convenient. I think in the install information, I think they have you connecting the relay pack, because there's 2 relays on a little board. I think they have you just putting it in the blower compartment, if my memory serves.
Okay.
So basically, there's some harnessing on there that'll be convenient, to stretch it. But I don't think there's enough room to put the relay pack inside that little enclosure on the variable speed air handler. So you'll mount it like on the blower housing, or you'll mount it like on the inside of the blower compartment. Typically is where they go. Good question. Okay, fellas, let's talk about that RV relay, the RV relay. So the RV relay, the other side of the relay coil on RV relay is going to go up to B terminal. And so what's going to happen is the RV relay will switch. It's going to switch anytime you get a heating call, for B for heating, for reversing valve operation. So basically, that RV relay, the only thing it does, it's going to sit here and switch when you have a B for reversing valve operation and heating. The common side, the common terminal of the switching contacts on the RV relay are going to grab 24 volts off the Y signal for compressor operation. So as long as the compressor is running, you'll have power to the common switching contact on the RV relay. Now watch this. The normally closed contact on the RV relay is going to go up and hit the O terminal. Now this is really important to get your mind wrapped around this. So on a variable speed air handler, or variable speed furnace, you have to have an O terminal, or have to have the O terminal energized in the cooling mode on a heat pump for advanced features. For instance, some of your dehumidification features on the HUME terminal for cooling dehumidification are driven by that input to the O terminal. In addition, you have to have that O terminal to get your cooling on delay, that ramping operation that you can do, to ramp that fan motor. If it's humid, you can start the motor out slow and then ramp it up to 50%, then 80%, and so on. So that cooling on delay feature is all driven by the O signal on a heat pump. So if you've got a heat pump outside, we need to see that O signal on the indoor unit in the cooling mode. In the heating mode of operation, we drop that O signal out. So that's the only thing that RV relay does, is in the cooling mode of operation with the normally closed contacts. As long as you got compressor operation, you're feeding power to the O terminal on the indoor air handler. And that O terminal is telling that indoor air handler, hey, I'm on a heat pump. I'm in the cooling mode of operation. However, when I go to heating mode of operation, I energize the RV relay and I switch those contacts, and then I tell the indoor unit, by way of the RV relay, hey, I'm in the heating mode now. So it's going to ignore the O signal basically because it's not there. So it knows not to do cooling, ramping, and all that kind of stuff. So the only purpose of the RV relay is to ensure that we have 24 volts on the O terminal in the cooling mode. Any questions or comments on that before we do a little animation for you?
I think so.
Okay, so basically you have two relays. You've got a airflow reduction relay, the S1 relay, like we've talked about from the beginning of the class, and then the RV relay, which is a O terminal switching relay to tell the air handler it's in the cooling mode or the heating mode of operation. That's the only reason that relay's there. So let's say, for instance, you had a two-stage furnace. Other than a couple of terminals that are, except for the heating terminals that are labeled slightly different, everything wires exactly like the AVC air handler we just talked about. So everything stays exactly the same. It's just that the terminals look a little bit different, and they're a hard screw terminal on the furnace. Take a look at it. Remember, the TMV furnace does require a dual fuel thermostat if you happen to hook up a variable speed furnace. So let's do some animations. Watch the relays. And as we go to airflow reduction, we generate an S1 signal just like we had before. And that switches that relay, that S1 relay, and it commands lower airflow. Then if we go to the heating mode of operation, you'll notice, let me back up. Watch the animation. When we go to heating mode of operation, we energize the B terminal, bang. Once we energize that B terminal, we switch that RV relay and we drop out the O signal to the O terminal. So now the air handler or the variable speed furnace knows it's in the heating mode of operation by way of the RV relay. Now, one of the things I'd like everybody to notice too, no matter what product that you put this with, and this is one of the reasons I really love the HMH7, it doesn't matter what indoor air product that you have or what indoor air handler or furnace you have, you still only have 5 wires outside for complete functionality. You're going to have a B, an S1, a W, a Y, and a C outside. That's it. Even on our most advanced variable speed product inside, yeah, we've got some relays or switching and stuff like that inside, but so what? Because outside, on all this functionality, 35 to 100% capacity, you still only have 5 wires outside. That's pretty cool. Any questions or comments on that?
What was the reasoning behind choosing relays instead of the communicating?
The reason they did that, that's a really good question. We wanted to have a high efficiency. In fact, the HMH7 is actually up to 18 SEER based on the indoor coil match and stuff like that. But we wanted a high efficiency mid-tier product that would be simple, easy to wire up with just a easy, simple, conventional 24 volt system. And that's what this is all about. So the real high end communicating stuff is 4-wire and 3-wire outside. And this is just a simple, high efficiency, 24 volt wiring scheme. And by the way, we've got a lot of these HMH7s. That was the other thing where we had access to them. They're a great product, and we got a boatload full of them basically. So, in the last year or so, we've had some allocation issues and stuff like that with other products, and this one's available and it works very, very well. And it's simple to hook up. So those were some of the top key factors when we were choosing this product.
And no allocation, right? First come, first serve?
No allocation on the outdoor product. So you talk to Tony about that. We've got a boatload of them, literally.
Now, are you ever going to go with a straight cool option for the outdoor unit?
That's a great question. As a matter of fact, this fall, I think we're going to be launching a straight cool variant of it. And again, Tony could give you more details on that when that would be available and stuff. But I'm thinking this fall we're going to launch a straight cool variant of the HMH7.
Yeah, that's a great question. That unit should be available, we're told, in September timeframe, and it is nominally a 16 SEER. So my understanding is it'll look basically just like the heat pump does. it'll be 16 SEER nominal.
Okay, great. Well, fellas, a couple other little things as we start kind of heading towards the end of our program today. There's a couple things I'd like to remind everybody. Please remember on every install to confirm your proper airflow. The HMH7 is a modulating system, and nominal airflow is going to be critical. Now, we want you to be sure and size your ductwork for 400 CFM per ton of total cooling capacity. And so again, on a 2-ton unit, you'd have 800 CFM. On a 3-ton unit, you'd have 1200 CFM, and so on. And the reason this becomes really important is because the modulating system, what it's doing is constantly monitoring the refrigeration circuit. It's looking at outdoor air temperatures, looking at suction line temperatures, looking at liquid line temperatures, looking at discharge line temperatures. And it's making all of these, it's got like 5 sensors, and it's making intelligent decisions on its point of capacity. So think about it for a second. If you had undersized ductwork or you had a restricted airflow, for instance, and on the return side, and you start, say, icing up the evaporator coil, well, what's going to happen is the outdoor unit's going to perceive that as a reduction in capacity, because it's going to see a drop in suction pressure, drop in suction line temperature, a drop in liquid line temperature, and so on. So it's going to perceive that as a reduction in capacity. So airflow becomes really, really important on a modulating system. And this is anybody's modulating system, because what it's doing is it's looking at the refrigeration circuit to make intelligent decisions, and outdoor air temperature to make intelligent decisions on its point of capacity. So airflow is going to be very, very important. The other thing we'd like everybody to remember too is take a look at that velocity table in Manual D. And just remember, you know, some of those velocity duct system components, the recommended velocity, you know, try to stay within those velocity limits. You'll notice, like on main trunks, for instance, Manual D talks about a recommended 700 feet a minute velocity moving down that main trunk. Returns are about 600, and so on. So just be aware of this, and we can get this table to you if you want it. You know, Tony can reach out with this stuff, but you know, this is just a quick little reminder that, you know, velocities are very, very important as well on branch ducts and registers and diffusers and grills and so on. I'm not going to sit here and read them all to you, but you know, it's important that we maintain the proper velocity in those duct systems as well. And then finally, if you do have, I know down in Florida, like we have in Alabama, you're going to have a lot of installations where you may have a filter grill. You may have a 1 or 2 returns with a filter in that return grill. Please remember, guys, on a return grill with a filter in it, Manual D recommends a maximum face velocity going across that filter of 300, not to exceed 300 feet a minute velocity. So we want to keep that system quiet. We want those filters to work well and don't exceed about 300 feet a minute velocity across those filter grills if they have a filter in them, which you probably have a lot of that down there in Florida. So just some airflow considerations to please remember and consider when you're putting in a modulating system, because we want that system to absolutely work at its optimal point of capacity and so on. So with that, I'm going to go ahead and open the floor up for any final questions and comments. I'm going to go ahead and put that PowerPoint down, and I'm going to come back here and turn my screen back on for a minute or two. And we're going to see if there's any final questions or comments that we could review for you before we secure for the day.
We do a lot of the 20 SEER variable speed. It's like my preferred system.
Good system.
Is this designed to kind of come in between like the standard 17 SEER and the communicating stuff?
You know, that would probably be a pretty good way to position it, you know, kind of a good, better, best type of thing. This unit actually goes up to 18 SEER based on your applications. But that would be a good way to position that, wouldn't you think, Tony?
Yeah, for sure. And so this HMH7 is replacing our TH16. The TH16 being a modulating system, traditional system. And what you have in between is the HL19, which is a 2-stage unit, versus this this is 17 SEER nominal modulating, just my opinion, I think you really get more value out of a modulating system than you do a two-stage.
I do
Particularly
too.
in Florida, where, you just really, you have that humidity down there that you just need to wring out. And I think, no, I think, great question. I think, this one would fit nicely. You have, basically, you could have single stage, um, 14 SEER in our TH4, and then move up to the HMH7 modulating, maybe as a consideration. And then you could position that HL19 in there in between. There's some benefits to that, certainly efficiency, quiet operation. It does have a lifetime compressor warranty and some things like that that are associated with our momentum line. It's in the momentum line, so it's upper tier. And then you position your 21.
Good questions.
And then price wise, does it fit into that scheme? Is that 18.7 with like an ABC air handler? Is that going to be less than a two-speed communicating system?
I think you're going to see that and I specifically, I'd have to take a look at it, but I think you're going to see that it's positioned. If you were using our 16 in your lineup, I think you're going to see that it's a little less than the TH16. And I know when I was in your plane,